the first thing to note is that SQL doesn't work directly with CSV files. Instead, it works with these databases, which are stored in .db files. And a database can be made up of hundreds of tables. And so you just have to trust that I preloaded this database with the same information that we already had in the charts and charts old data frames, and I did. And so within here are the tables that we want, or the relations we want. Okay, so how do we write a query? Well, how do I just see a table first? Like, it's not clear how I do that. Well, the strategy is you use select star from the name of the table you want. So let's say we want charts. You end your query with a semicolon. The issue is this is going to show me every row in the data set. Okay, it shows me all 200 of them. So if I want to make this a little shorter, I can say, hey, just show me the top 5. How do you do that? Limit 5. Okay, so now I just see the top 5 songs on the charts, same as when I had it open as a data frame. Okay, we can work through the syntax in a vacuum, but remember, our goal is to answer these 6 tasks. So let's explain the syntax we need to do those. First, how do we find the total number of streams of songs by Sabrina Carpenter? Well, conceptually, what do we need to do? We have a huge data set. What we want to do is query just for the rows pertaining to Sabrina Carpenter songs. Do we agree? Okay, how do I do that in SQL? Well, also, this is just annoying to look at, so I'm just going to restart this. What I'm going to do is select star from charts, is what I called it, where, this is how I add a condition, artist names equals Sabrina Carpenter. Okay? Single equal, not double equal. But this is showing me all of the songs just for Sabrina Carpenter. So this is like querying in data frames. Do we agree? Okay, the terminology is a little weird because for us, querying is one very specific thing. It's picking rows that satisfy a condition. In SQL, everything is called a query. But it is what it is. But are we clear on what we've accomplished so far? Okay, now the question is, how do I sum the streams column? Here's how you do it. You specify at the top that what you want is not the full data set, but you want the sum of the streams column in this data set. Okay? Again, syntax is a little weird. You're saying steps before you thought you would have to say them relative to how you would do this in pandas. Because in pandas, you query first and then say sum this column. Here I'm saying I want the sum of the column at the top. It's not that I'm summing stuff before I filter. It's SQL's job to figure out what order to do this in. I'm writing it this way because that's just the formula for writing SQL queries. Okay, the number ends in 137, and so does the answer we found in Python. So hopefully they're the same. Okay, so we've implemented our first SQL query. Do we agree? Okay, let's try a more complicated one. Find the total number of streams per artist, sorted by number of streams in descending order, only show the top 5 artists. So I need the total number of streams per artist. This is tricky. How I can do it is, eventually I'm going to have to say something about grouping by artist names. And that's part of the syntax we can use. But the tricky thing is, ahead of time, I'm going to have to say sum the streams column for each artist. And what I can do is rename this sum of streams column to whatever I want to call it. So I can say, hey, instead of calling it sum of streams, I can say call it total streams. And unlike grouping in pandas where, the index automatically just has the unique values of the column you grouped on, in SQL you have to ask for those values. So I'm going to say select artist names and the total streams from charts, group by artist names, and then I'm not just going to do that. I'm going to order by total streams in descending order. I'm not just going to do that. I'm going to say, hey, only give me the top 5. OK, before we walk through what just happened, you got a question?
I was just going to ask about the capital.
Yes, good question. Why are some things capital? Turns out it doesn't actually matter. You can make the select, group by, order by, limit, descending all lowercase, and it still works fine. There's just convention in SQL to make the variables lowercase, and the operations uppercase. Okay, so let's walk through what we did. We said, hey, for every artist name, remember grouping always, the way you should read that is for every unique value in this column. So for every unique artist name, sum the streams column. And all I'm saying is, hey, sum the streams column, but in the resulting table you give me back, call that summed streams column total streams. That's all I'm asking for. And I'm saying, hey, okay, once you do all that, order the resulting relation by total streams in descending order. And then, now that I've done that, I can cut off just the top 5. Okay, so again, syntactically, this is maybe a little strange. But conceptually, you know how to do all of this. Right? It's just, you tell the computer to do it a little, how you tell it to do it is a little different. Okay, questions with our second SQL query? Following so far? Okay. That looks right. 137, 821, 557, 137, 821, 557. Okay, numbers look good. Here's where DuckDB comes into play. So far we were using SQLite and we were doing things in our terminal, but it would be nice if I could write out my SQL queries not line by line. It'd be nice if I could do the group by part first and then go back to select, right? It turns out that there's a database engine or a database called DuckDB, which is relatively new. It only was created in the last 5 years. That is open source and works with Python. All you have to do is pip install DuckDB and then import DuckDB. And the cool thing with DuckDB is that it allows you to work directly with data frames. Okay, and here's what I mean. Just run this function that I defined. All it's doing is using duckdb.query. And what you can do is you can give DuckDB a string that contains a SQL query. And what it will do is anytime it finds a data frame that is currently defined in your notebook, it'll just use that as a SQL table. So right here, charts is a data frame that already existed in my notebook. And so it's going to interpret that as a SQL table, and it's going to run this SQL query directly in the notebook. It gives me back the same result that I saw in my terminal. Okay, so it's like doing SQL in a Jupyter notebook. You can actually even do more than that. You can tell it, don't just render it as this weird table thing. Give me back a data frame. So what this did is it ran this SQL operation and gave me a data frame of the result. And what this means is if I wanted to, I could use DuckDB and pandas at the same time. Some operations I could do with DuckDB, but then now that I have this data frame, I could say, artist names.str.split 0, str.split.str0, and I've combined SQL and pandas code. Okay, this particular example is not one in which I would do that, but you could do it. Okay, and so for our remaining examples, we will just use this run SQL function that we made. Sound okay? All right. Okay, more tasks. So I'm going to start by initializing an empty multi-line string. Find the artist with the lowest average number of streams among artists with at least 5 songs in the top 200. Okay, a lot of stuff going on. But conceptually, when we did this in pandas, what we first did is we filtered out all the artists that don't have at least 5 songs. Remember, I did .group by artist names, .filter, something greater than or equal to 5. Sound familiar? I need to figure out how to do that in SQL. And I'm somewhere in here, I'm going to have to group by artist names. The new keyword that I need to tell you about is called having. Okay? Having is like filter. It's where you only keep groups that satisfy particular conditions. Okay? And what I'm going to do is I'm only going to keep the groups that have a count, and I'll make that uppercase, of at least 5. Okay? Again, syntax is a little weird, but conceptually, it's doing what we've seen before. Okay, this is like filtering. What am I going to do? Well, I'm going to have to find the average number of streams per artist. So maybe like before, I'll keep around the artist names, but I'll also average the number of streams. And so the question is, how do I find the average of a column? We know sum finds the sum of a column. To compute the mean in SQL, you use AVG for average. Okay, so I'm going to average the streams. Now, I can call this whatever I want it to. Mean streams. I can do this from charts, having group by artist, having count greater than or equal to 5. So this will give me the average streams for every artist with at least 5 songs. But I didn't fully answer the question. This is just the average streams for the artists with at least 5 songs. What does the question ask for? Yeah, it asks for the lowest. So what I need to do here, well, I can see that it's Bruno Mars here, but how would I get SQL to find that out? Well, I could order by mean streams in descending order and just take the top row. Well, not descending order, ascending order, which is the default. Okay, and then we see the same value we had before. Remember, E plus 07 is just times 10 to the power of 7. Times 10 million. Okay, so do we agree that SQL is doing the same thing that we were able to do before? The way you write the code is weird, but conceptually it does the same thing. Okay, next task. Find the number of songs with a higher ranking this week than last week. So this one's a little strange. Well, they're all a little strange, but stranger than even the other strange ones. Querying, or using where to find all the rows where the ranking this week is higher than last week, that's not the hard part. I could say select star from streams, or charts, sorry, where rank is greater than previous rank. That alone is not hard. And if I want this back as a data frame, I could say as df equals true. And we see that this data frame has 119 rows. But in SQL land, I don't know how many rows are in this table. Well, I can see that. But again, programmatically, I haven't figured out how many rows are in this table. Do we agree? What is the equivalent of .shape0 for SQL? Well, there are perhaps other solutions, but one solution is to use a nested query. So what I can do is say, hey, select count star from this thing. Okay. Now, is a nested query necessary here? Not really. You could also just have done select count star here, I believe. See if that works. But nested queries more generally will appear quite a bit, where you need to do one operation and then do a further operation. Do we agree? Okay. Task 5. This one is really complicated, and because I want to move on to the sheets section, I'm not going to walk through it right now, but it involves joining 2 tables. Okay, I'll show you the basic syntax of how you do the joining, and then the rest of it, it's posted online, so you can take a look at sort of how we would do that. What I might do is say select the URI, the track name, and the streams from charts, inner join, or join. The default is inner join, but of course SQL knows about left, right, outer. I'll say join this on charts old, which was the other data frame that I defined over here with last week's rankings. Okay? I need to specify what my join key and my join condition is, right? And conceptually, what would I use to merge charts with charts old? Oops. How would I combine these 2 frames? What column? Because there are a lot of shared columns, right? In fact, any of the columns could be used technically, but conceptually, what should I use? Yeah, URI, right? Because that's the only thing that uniquely identifies a song. Maybe track name does too, but what if there are 2 songs with the same name? There could be. So I'm going to have to tell it to merge on the URI column. But the tricky thing is you have to explicitly tell SQL when you're working with multiple tables which table each column came from. So I'd have to say something like select charts.uri, charts.trackname, charts.streams from charts, joined on charts old, joined with charts old on this condition. Charts.uri equals chartsold.uri. Okay? The issue is in this resulting data frame, we're not going to bring any information from charts old either. So we're going to have to say, hey, bring charts old's streams column 2. Okay? And this is how I would find the number of streams this week and last week. What's tricky about this? Well, it seems like there are 2 columns, both called streams. How do I know which one I'm working with? Well, I can make that a little more straightforward. Oops. Let's clean this up a little. Hopefully this still works. I believe it will. Okay. I can use the as keyword to rename them to whatever I want. So I could say this is now streams new. This is streams old. Okay. And it has streams old and streams new columns. Do we agree? Okay. And then from this table, how would I find the song with the highest average increase in streams? Well, I could use another subquery, right? I could say, hey, do all of this stuff, and then from this table, select track name and the difference between streams new and streams old. So I can specify my series operation in our terminology up here. Saying, hey, not only should you select the track name column, but also select this column that finds the difference between the 2 columns here. And maybe I'll call this something else, like change or increase. From. There we go. So these are songs with increases. And now I can do stuff like order by, increase in descending order, limit 1, and we see the same information we had before. Okay? So a lot of it is still possible. It's just what paradigm, like how do you want to think? Do you like thinking this way? Do you like thinking the pandas way? There's no right answer. I mean, of course, I'm biased. Most of the class has been in pandas so far. But if I really like SQL, maybe most of the class would have been in SQL so far, and that would be the way you prefer. Right now, this may seem foreign, but maybe you find that you like this sort of style of thinking better, and you could use this sort of syntax to work with data frames if you really wanted to. Okay. Last thing I'll show you, I know I said I would move on to the sheets thing, but I want to finish this thoroughly, is that there's many operations that SQL is not super well suited for, and stuff like finding the songs with, or finding the number of artists per song is tricky to do in SQL. Okay. Again, here I'm defining the number of artists in a song as being the number of commas in the artist name plus 1. Okay, and I know how to do that in pandas. I can go to the artist names column, do .str. I can even do .str.count. How many commas followed by spaces are there? Add 1 to that. That tells me the number of artists. Can SQL do that? Well, it turns out not every SQL can. DuckDB SQL can, because it's relatively new. But what I'm about to show you wouldn't work in SQLite. So if we went back to our terminal, what I'm about to show you wouldn't work. Okay, so this is where different SQL dialects support different syntax. So what I'll do is, hey, I'm gonna select, I want the name of the song. Well, let's look at charts first. I want the name of the song. Here's we'll bring along the name of the artists. And I'm gonna take this from charts. And somehow I'm gonna have to figure out the number of artists per song. And as we've seen, if we're doing computation with a column, that all happens in the first line of our query. Just like in the previous query, we found the difference between 2 columns. That happened at the top. This is going to happen at the top too. How are we supposed to figure out the number of commas in here? Well, one solution I found is to use this array length function, built into DuckDB SQL, but not SQLite. Then there's also you got tired of listening to me. There's a string split function built into DuckDB SQL. Okay? And what we can say is, hey, split the artist names column by a comma and a space, and to that value add 1. Okay? Do all of that, and call that a num artists column. And now I can say, hey, well, now that you've done that, order by the num of artists in descending order, give me the top 4. Uh-oh. Strings. That's what we had, I believe. There we go. And it gives us back the same information. I think I just did this incorrectly. Don't need the +1 there. There we go. Okay. This is the sort of thing that would be, I think historically people wouldn't use SQL for. This like very data cleaning type stuff is what pandas and R are better at. Working with large data sets where you want to do your analysis later on, that's sort of what SQL is meant for. Okay, but newer distributions of SQL, like DuckDB, allow us to do stuff like this. But again, if you took this exact query, went back to your terminal, it's not going to know what to do with it. Okay, it's going to say, hey, there's an error here. Okay, because different databases support different dialects of SQL. Okay, what questions do we have with our treatment of SQL so far? Okay, high-level takeaway, are you supposed to be a master at SQL already? No, of course not. But you should know that whatever you know how to do in pandas has a SQL equivalent. It's just a matter of figuring out what words to use in what order. But conceptually, you knew how to answer all 6 of these tasks, right? First, pick the rows where this condition is satisfied. Then make a new column where you do column X minus column Y, right? Those are all generalized operations that you're familiar with. And so like, for example, in data scientist internship or like full-time job applications, they often ask you to answer questions in SQL. Okay? And my point is that a lot of what we've done here translates over to the sorts of problems that they could ask in one of those interviews. You know conceptually how to answer these questions. It's just a matter of figuring out the syntax. And we've covered enough examples so far today that you have quite a bit to work off of. Sound good? Okay.